In this video, we're going to talk about how we solve equations that have variables inside of square roots. So let's get right into an example. Let's say I have the equation square root of t plus 2 minus t equals negative 4. So to handle something like this, what we need to do is we need to isolate the root and then square both sides. So I got to take this minus t and then add it over to the right. So that'll give me square root of t plus 2. And then equals, it'll be positive t minus 4. Now I can square both sides to get rid of that square root. So square both sides. And if I do that, it cancels out the root here. So I'll get t plus 2. And on the right-hand side, well, to do t minus 4 squared, remember, if I'm subtracting or adding terms, I'm not allowed to just distribute the power. What I have to do is write this as t minus 4 times t minus 4. And then FOIL this out. So if you FOIL that out, you'll get t squared, right, from multiplying these two. And then from multiplying these two, I'll get minus 4t. From multiplying these two, I'll get another minus 4t. So that makes a minus 8t. And then from multiplying the last two terms together, I'll get plus 16. Okay, so nice. So now, I'd like to move all the terms to one side to get one side to be 0. So let's subtract the t over and subtract the 2 over. So that'll give me 0 on the left equals t squared. And I'll get minus 9t plus 14. Okay, so now hopefully this quadratic factors. So I want to give you all, take a quick 30 seconds and try to factor that. So pause it in 3, 2, 1, pause it and try to factor that. Okay, so hopefully you did that. Hopefully you paused it and tried to factor it. So because this quadratic, its leading coefficient is 1, we just got to find two numbers that multiply to positive 14 and add to negative 9. And what works is if you do minus 7 and minus 2, and now that it's factored and it equals 0, well, from the first parentheses, I get that t equals 7. And from the second parentheses, I get t equals 2. Okay, so we got these. So it turns out that when we have an equation with a variable inside of, it could be any type of even root, like a square root, it could be a fourth root, or it could be a sixth root, any type of even root, we got to check for extraneous solutions. So we are going to have to check for extraneous solutions. And I'll talk about why in just a couple of minutes, but for right now, let's do the check. So let's check for the extraneous solutions. So let's plug both of these in. Let's plug in t equals 7 and t equals 2. And let's plug them into the original equation. So if I do that, I'll get the square root of 7 plus 2 minus 7. And I'll put equals question mark. I'll put a question mark on the equal sign because I don't know if they're actually going to equal, if this will work. And then minus 4 here. So I'll get the square root of 9, which is 3. And 3 minus 7, question mark, does that equal negative 4? And yeah, I get negative 4 on both sides. So this works. So I'll put a smiley face. This ended up working. Okay, and now let's test out the other value. Let's test out t equals 2. So if I plug in t equals 2 into this, on the left I'll get the square root of 2 plus 2 minus 2, and then equals question mark negative 4. So I get the square root of 4, which is, well, that's 2. And then I'll get 2 minus 2, question mark, does that equal negative 4? Well, now the left-hand side becomes 0. I'll get 0 equals a negative 4. Well, those are clearly not the same. So I'll put a sad face. Sad face, which means that this answer, the t equals 2, I'll put a slash through it. That's extraneous. And I only have one answer. Only t equals 7 ended up working. Okay. So one other thing I want to mention about this, I won't write anything down here, but it's really tempting when you have an equation like this to be like, okay, let me just square both sides. Let's square both sides right away. And then to want to take that squared and distribute it here and distribute it to that minus t. But I can't distribute a power when you're adding or subtracting terms. So we really do need to isolate the square root first before we square both sides. That's super, super important. Okay, so let's do another example. So what if I had the square root of t plus 2 equals -4? So I'm going to solve this in two ways. First, I notice the square root is already isolated. Let's just square both sides. So if I square both sides, I'll get t plus 2 on the left. I'll get 16 on the right. And then if I subtract the 2, I'll get t equals 14. I get t equals 14. And then because I had a variable inside of an even root, I need to check this answer. I got to check it to see if it works. We got to check it, and if I plug in t equals 14, if we take t equals 14 and we plug it in, I'll get the square root of 14 plus 2 equals question mark. Does it actually equal -4? Well, on the left I get the square root of 16, which is 4. And 4 definitely does not equal -4. So, okay, I'm going to put a slash through this answer and say it's extraneous. And overall, what that means is when I solved this, I got one answer. And because it did not work, that means there are no solutions. So no solutions to this equation. So let's talk about another way we could get that answer. And this is going to be a little quicker. And that's to realize that, well, when you do the square root of some stuff, so on the left-hand side, I have the square root of some stuff. Well, that is not allowed to be a negative number. That's not allowed to be negative. Whatever you plug into the square root, the output has to be non-negative. So if I notice that right away, I would see that, oh yeah, the square root of something, there's no way that could end up equaling -4. And based on that, I can say, well, so this has no solution. So this has no solution. Okay, that's another way I could have gotten to that answer, which is a little quicker. So now I want to revisit this question of, well, why is it that equations that have square roots like this can produce these extraneous solutions? Like, why is that even a possibility? So, well, if I look at this equation that we had in part B here, when we squared both sides with this equation, what it gave us was t plus 2 on the left, and it gave us -4 squared on the right. And what happens when we do that is, initially, we have something that's impossible. The square root of something can never equal a negative number. But when we square both sides, the square root is gone. And without the square root, well, t plus 2 by itself, it could equal whatever. It could equal a positive or a negative. So when you square both sides, it removes this restriction that the square root of some stuff is not allowed to be negative. And the fact that that restriction gets removed opens up the possibility that we get extra answers that don't actually work. So that's why this is even a possibility in equations that have square roots. Okay, so let's end this video with one more example, but let's up the difficulty a little bit. Let's do one where we got two of these square roots. Well, to get it started, I'm going to try to isolate one of them. So maybe I'll isolate this one on the left, and I'll move this one over to the right by adding it. So that'll give me a square root of 3t plus 1. And then if I add the other one over, I'll get 1 plus the square root of 2t minus 1. Okay, now let's square both sides. Let us square both sides. So square the left, square the right. And when I do that, on the left, I'll get 3t plus 1, because that square root will cancel. And on the right, again, it's really tempting to try to distribute the power to each of these, but I cannot do that because these terms are being added. I cannot distribute a power when adding or subtracting terms. Instead, I have to write this as 1 plus the square root of 2t minus 1 times itself times another 1 plus the square root of 2t minus 1. And then FOIL this out. So when we FOIL this, you multiply the 1's together first, and you'll get 1. Then you multiply the 1 times this square root. And then also when you multiply these, 1 times the square root, that's going to give me the square root of 2t minus 1 plus another square root of 2t minus 1, which becomes 2 square root of 2t minus 1, because those are like terms. And then finally, we got to multiply the last terms together, which will give me the square root of this times itself, and that'll cancel the square root. That'll just give me 2t minus 1. Okay, nice. So at least one nice thing is, before we had two roots, now there's just one. And let's simplify what we can. So I see a plus 1, I see a minus 1 here. Those will cancel and just give me a 0. And then what else can I do? Let's try to isolate this square root now. So I'm going to take this 2t and then subtract it over to the left. That'll just give me t and then plus 1. And on the right side, I got 2 times the square root of 2t minus 1. Okay, so from here, I could divide this 2 over if I wanted to isolate the square root and then square both sides. But I notice that, if I leave it like this and square both sides, I avoid the fraction altogether. So let's try to square both sides at this step. So let's square both sides here. And I notice that now the 2 is multiplying this square root. And because I'm multiplying terms, I am going to be able to distribute this power to each one. So from here, I want to give you about 3 minutes to pause this and see if you can carry it forward on your own. So pause it in 3, 2, 1, pause it and try this. Okay, so hopefully did that. Hopefully paused it to try it. Let's talk about it. So on the left, I got to do t plus 1 times another t plus 1. So I'm gonna leave it to you to FOIL that out. But if you do, you'll get t squared plus 2t plus 1. On the right, remember I get to distribute this power because the terms inside are being multiplied. So I'll get 2 squared, which is 4. And then when you square this square root, it'll cancel the square root, and you'll just get 2t minus 1. And then if I distribute that 4, I'll get 8t minus 4. Nice. Okay, so now I can move all the terms to one side and get the other side equal to 0. So I'll move this 8t minus 4 over, and that's going to give me t squared. Let's see, I'll get minus 6t plus 5 equals 0. And I'm running out of room, so let's carry it forward on the next page. But I got a quadratic. The leading coefficient is 1. So this should just factor as t and then times something, t times something. I need two terms that multiply to 5 and add to negative 6. So what works is minus 5 minus 1. So now from the first parentheses, I get t equals 5. From the second one, I get 1. Okay. And then because I had variables inside of even roots, I have to check for extraneous solutions. So let's check. Let us check. Okay, so first I got to check t equals 5. T equals 5. Let me just make sure I can see the original problem. So that'll give me, if I plug it in, square root of 3 times 5 plus 1 minus the square root of 2 times 5 minus 1 equals question mark, does that equal 1? So this first square root becomes square root of 16, which is 4. And then I get minus. The next one's square root of 9, which is 3. And does 4 minus 3 equal 1? Yeah, those are equal. Those are equal. So smiley face. And then I got to plug in 1. So now I got to plug in t equals 1. So if I plug that in, I'll get the square root of 3 times 1 plus 1. And then minus the square root of 2 times 1 minus 1 equals question mark. Question mark, is it going to equal 1? So the first square root is square root of 4, which is 2. And then minus, I get the square root of 1, which is 1. And 2 minus 1 does equal 1. So this one works as well. So smiley face. So actually both of these answers work. So I got 2 answers, t equals 5 and t equals 1. So when you have these problems where you got to check for extraneous solutions, sometimes all the answers are going to work. Sometimes, like in this problem, just one of them is going to work and the other one won't. There could also be a problem where none of them work. That is also a possibility.